My name is Diane Davidson. I'm the Center Director for Center for Transportation Analysis at the Oak Ridge National Laboratory, and I welcome you to the breakout session on TMC evaluation and decision support. We're going to get started right away because we have 4 great speakers for you. What I have up here, just to kind of whet the appetite a bit on visualization of ITS type assets, is a tool that ORNL has developed in concert with JPO, taking database that we've maintained for many years on tracking ITS assets in all the states and the metropolitan areas, and displaying it visually. So what we're showing here are all the camera locations, so I think you can see the URL up above here if you'd like to get into this and play with it later. So you can see, can drill down into areas, and one of the things that in terms of decision support that this is particularly good for is this resolution. You can actually begin to see your locations with some information on, for instance, this is the cameras, type of cameras, model of cameras in a lot of situations. And so one of the decision support aspects of this is you can see where you're beginning to have a density of deployment, and that can help with prioritizing future deployment and acquisition of assets. So didn't really want to take a lot of time from our speakers, but did want to show you this little tool that, since you have an interest in ITS, different types of ITS. This is urban at this point. Let me go ahead and write this. But this year we're beginning to work on rural deployment, and we'll be adding the rural assets to this in the next year. With that, the rules of the game here this morning, we have 4 speakers. They're all excellent. We have a lot to show you. They each have 15 minutes plus 5 minutes or so for questions. So I encourage you, we're going to ask questions after each presentation. And our first up is Nikola Ivanov, University of Maryland, the CAT lab. He promised yesterday he would wear a bow tie. I don't know if those of you were here when he promised that, and he did. So we're off to a great start then.
So I hope people don't start walking out since they've seen that I got the bow tie on and they're done, so they might go somewhere else. So I'll talk a little bit about what we've done at the CAT lab in terms of helping out with some of the dashboards that show some of the real-time information that we use for decision making. So most of you know what the real-time operations data looks like, and it's probably something like this. We have data coming from the sensor networks out on the road, incident information coming from the TMCs, from the patrols out on the road. All this data is coming into the traffic management centers, and it probably looks a little bit like this. And so if you think about the operators that have to deal with it, they might be looking at pages and pages of data trying to make sense out of it, and it's not a really efficient way of making sense of the situation out of the road and getting that situational awareness. Now you throw in some additional data that's usually present in TMCs, and you're looking at radio communications that's coming in real time. You look at the video data that's coming in, and most of the TMCs have those big video walls, so you're looking at those, you're trying to make sense of what's going on. Weather data, you might have a weather front coming through that might be affecting what's going on the road, and that might be in a different application. That might be a weather channel application, it could be something else. So now you have an operator that has to deal with those pages of data that are coming in from the sensor networks, but also these other types of data, just trying to figure out what is it that's going on out there, and how do you make decisions based on that information that you're getting. So that's not very easy to do in the format that I just presented. So what we tried to do is we tried to take that information and extract what's important, extract and boil it down to something that's digestible, that's easily understandable, and also something that you can act on, something that as you're looking at it, you can make changes and see how the situation actually shifts. So what we do and what most people do is they take maps. Most of this data is geospatial in nature, so they take maps and try to overlay information on it. But how do you make sure that you're not overloading that dashboard? How do you determine what's important? And that's a challenge. The other thing that's important when you're doing something like this is actually to make it scalable. So, you know, the data that I was showing you earlier, it's difficult enough for a single event, but now if you're looking in multiple jurisdictions, it gets even more difficult. So how do you make that data scalable across large areas? So in this case, you know, looking at the national coverage of the U.S. and seeing all that data in that one dashboard is a challenge, but it's also something that makes it significantly easier for operators to actually make decisions. So I will actually jump into a live demo here and show you a few things. So what we've done is we've taken that information and we tried to make it understandable in a meaningful way. And so what we did is we took the real-time information and we created this incident list that shows you what is going on the road right now. And it shows you who the sources of the data are and shows you who the sources of the data are, where those events are happening. I think this is doing something to it. It's refreshing it. And then where those locations are, what type of an incident. There's a lot of construction happening right now, and this is, I'm actually, the region of interest that I have selected is Maryland, DC area, since that's where we are located. So what you're seeing is a lot of construction events. You can see the lane closures, some additional information. Makes it easy to kind of have a quick overview of what's going on, and you can sort by any of these. So if you're interested in things that might have a high impact based on lane status, you can actually sort by it and see where are the major lane closures and follow that. So as I was saying, taking that to the map view, since most of this information is geospatial, because you may not know where I-95R is. What you can do is you can plot that data on the map, and you can get an idea of where the problem spots are. So as I mentioned, most of the area right now is seeing a lot of construction events because it's midday, about 12:10 over there. But you can see a few things here together. So you have these incidents. These icons that are flashing, they have been updated in the last 5 minutes or so. And then you have the speed information, so you can kind of get an idea of what's going on. Now, if you're familiar with DC region, usually things are significantly slower. So what you're seeing here is everything is green. That doesn't necessarily mean that everything is moving at 70 miles an hour. What we're doing is we're actually looking at comparative speed. We're comparing the speed to the same time, same day in history. So for example, we're looking at Thursday at 12:10 p.m. What are the normal conditions? Comparing that on the fly and then showing you the problem spots only. So what you will notice is everything is green because everything is mostly normal. And then in DC here you have a couple of red spots where actually things are not normal. They're slower than usual down here too. So you can probably assume that that's related to these construction events. You will notice here we have a whole set of different data, and I will not go through everything, but as I was mentioning earlier, we integrate things like scanners, radio scanners. So if you have an incident, large incident in some location, you can actually open up these radio scanners and you can listen in. So there's a particular county where an incident has occurred, you can listen in and see what the EMS and fire, police are doing, how they're attacking this particular issue. We have things like dynamic message signs, so you can see what's posted on the signs, actual speed information coming from the detectors with some historical information over the last 12 hours, so you can just get an idea of what the trends are for this particular day. So this type of a dashboard gives an operator an opportunity to see and gain that situational awareness in a fairly easy manner. You don't really have to do a lot of interpretation of the data. It's supposed to be intuitive. The colors, the views are making it easier. And the other thing is you can control what is it that you're interested in. So you may not be interested in weather information, but you may be interested in point detector speed, so you might have that layer turned on for you. So taking it one step further, I was showing you earlier that view of all the data that you're getting and how difficult it is to make sense out of it. So if you take a particular incident and you're wondering what is going on with it, what we did is we developed this other dashboard type of a tool that tries to integrate all this data into a single page. So instead of you looking at multiple data sources and figuring out what's happening, you look at something like this. So in this particular case, it's a timeline. So you have time across the top here, and then different data sets vertically. And up here you can get some initial information. So this was a collision with a personal injury that involved one vehicle and a tractor trailer with wet weather conditions. And what you can see is, so we have the Traffic Management Center communication logs here. So you can see what different transportation management centers were doing during this incident. And if you hover over these, you will see what they were actually saying. So at Transportation Operations Center 7, Unit 9703 was advising 2 vehicles were involved in a 1050. And then statewide operations center was rerouting traffic through the right shoulder. So you can see this communication in real time. Now this is an archived event, and this is available for all the archived events. But if this was a real-time event, you would actually see everything being updated in real time. These little clips would pop up. Down here you can see the response to this incident. So each dot represents when a responder was notified, and then the dotted line is how long it took them to get on the scene, and the solid line is how long they've been on the scene. So in this particular incident, you'll notice that the chart unit, which is the State Highway Administration, Maryland State Highway Administration patrol, was notified, and it took them a few minutes to get to the scene, and then they were there for the duration of the event. But you will notice what's interesting about this view and this dashboard is actually seeing how these different data sets interact with each other. So you have lane closures that are caused by some of these responders that are coming on the scene and trying to take care of the scene. So you can see that when the police and fire showed up on the scene, they shut down the entire northbound lanes here. And then when medevac was called in, they had to shut down the other side of the road right before the medevac appeared for them to safely land. So you can see the correspondence between these two actions. And as an operator, you can make decisions based on this, whether or not the lane closures are causing additional delays. And what you can do is, like I mentioned, you're actually integrating other data sets as well. And one of the interesting integrations here is the speed information. So what you can see here, for this particular event, you can see a speed profile. So the black line right here is representing the incident location. So your traffic is moving in this direction. That's 5 miles behind, 10 miles behind the accident. That's time still. What you're seeing is that the queue is building up both in space and time. So for this particular incident, this set of lane closures has caused almost a 10-mile backup that lasted for a good few hours. And then even after the incident was closed, which is this green line, it takes quite a while before that queue starts dissipating. So you're really seeing the impacts of these lane closures, these responses, on the traveling public. And then I didn't show you this, but you also have overhead message signs. So at the beginning of this event, it said there was an accident, and then it switched back to road work, which was probably a timed DMS, and so they realized that was wrong, so they switched it back to the accident DMS later. So you can have some operational after action reviews to see, okay, here's what we did, and the sign has switched over. How long did it take you to realize that before switching it to the appropriate message? So that's kind of the real-time information that's oriented towards incidents and operational data. But what we did also is that we looked at the bottlenecks. So some of you might have seen this yesterday, or some of it yesterday during our demo outside in the lobby. But what this is it's focusing a little bit on speed data and determining where are the problem spots in a given region at this time. So what you can see here in this view is a similar map with the incident information overlaid on it, and then a bunch of these blue dots. And each blue dot is actually representing a currently, it's representing a current bottleneck that's happening right now. And if a dot has a tail behind it, and since I'm zoomed out pretty far away here, you don't see many of them. Plus, it's noon, so the traffic is not that heavy. But the tail behind the bottleneck will actually show you how bad that bottleneck is. On the left side, you see that list. So instead of in the case when there's no major bottleneck in the state that would pop out immediately in this picture, you can look up here and you can see they're actually sorted by their impact. And what you're seeing here is the length of this highlight represents how long the bottleneck is in distance, so how many miles. And if it's longer than 10 miles, the entire thing would be filled. 7.5 miles, 75% of it would be filled, and so on. And then the color represents what is the duration of that bottleneck. How long has it been in existence? So the red ones have been around for longer than some of the orange ones and yellow ones and so on. And then what you can do is you can actually click on them, and it will take you to that bottleneck, and it will show you some additional information about it. So it'll tell you where it is on the map, and it'll show you what road it's on, when it started, how long it's been in existence, what is the queue length, and then some information related to travel time index and the queue length. This is not particularly interesting. As I mentioned, this is a midday view, but what you can do is there's a time selection tool here. So I'm going to use that to go back in time and look at the morning rush hour. So this is what the morning rush hour looked like in DC, and it's significantly different. What you're seeing here, the only difference is that the background here is gray because we're looking at a past data set. But what you would be seeing this morning is a ton of different bottlenecks, and you would see that most of it is red, so they've been in existence for a pretty long time, and then the distances are pretty long as well. So this gives you an idea of recurring congestion that you might be seeing, but also things that are caused by incidents. So in this particular case, this morning, there was an incident here on looks like 495 spur, which is 270 comes down to 495 and splits into two different directions of 495. So there's an incident there. Most folks are driving in from the suburbs into the city, so there's a huge bottleneck heading down on I-270 trying to get into the city. So you can overlay that information together and really figure out what's causing the bottleneck. So I'm not going through all the other details. There are quite a few small features that help you customize and understand this information better. But the goal here is really to use the information in a meaningful manner that helps you make these decisions. So I'll jump back into my presentation. I have one more slide here. Okay on time here. So what are some of the next steps? What could we do to make this dashboard even more useful and make it better? And what I did here is, and this is just a mock-up, but what you could do is you could take that incident list that I was showing you earlier that currently shows the lane closures, the locations, and so on. So in those instances, you're kind of trying to figure out what the impact of that incident is based on those lane closures, based on the amount of information that's coming from the operators that are putting in the information. But what you could also do is you could calculate things like the user delay cost. So given that we have the speed information, we have the number of lanes closed, we have the information as to what type of a road it is, you could calculate that information and show it in real time as well, so that you know that this incident that has, or a construction event that has closed the entire side of the road here is costing about $250,000, and that will be updating in real time. And then you can also take those bottlenecks that I was just showing you in a different view and displaying that information so that you can judge what the impact of the event is in terms of the bottlenecks that are building behind it. So that's something that we're looking at doing. Again, some of these measures are not easy to do in real time, but they're possible. So it's something that could be done to improve. So with that, I will end the presentation and I will take any questions. Yes.
Can you say a bit more about what is the technology behind the tool?
Sure. So there are a lot of different things that go into building these types of tools. Some of the back-end data storage is based on PostgreSQL database, which is an open source database. We're also using some of the more distributed systems, such as Hadoop and HBase for some of the large data sets. Then as far as displaying, the map that you're seeing is something that we've built based on University of Minnesota open source map, but it's heavily modified to work with what we're doing. And then all the layers are built upon that using JavaScript and some of the HTML5 as well as some of the Flex. Now we're moving a little bit away from Flex more into HTML5 technology, but that's general feel. Yes?
So just like to mention that, so I'm with INRIX and we've worked with the University of Maryland to load a nationwide data set in a dashboard viewer, and if you missed our email blast, we're offering a free view of that. And so it's loaded with data live across the entire United States. If you'd like 1 month of access for a county of your choice to play with that, give me a card.
Great question.
Couldn't resist.
Any other questions? All right, thank you.
If we have time at the end of the session, if you've thought of any additional questions that you would like to address to any speakers, I think we'll have a little time to do that. So as we're getting ready, the next presenter is Mort Fahrtash, and he's with Caltrans District 12. His presentation is on TMC performance evaluation, and I think the benefits shown in this tool that you just saw and this presentation that we're going to hear now are vitally important, because all too often we're deploying a lot of technology and yet we haven't collected the benefits of that deployment, and we need to actually get better at that. So I look forward to your presentation.
Thank you very much. Good morning, everyone. I'm Mort Fahrtash. I'm located here in Orange County. The TMC is here to manage the traffic system on the freeway in Orange County, and I'm so glad that I was situated right after you. Nikola talked about the incident management, lane closures, patrol closing the freeway, response team from the center doing this, and he showed you a queue. And even if the traffic is restored, still queue is building up. It takes time to dissipate. And a lot of things that he talked about is what they do in real time to manage the traffic. Now, in order to evaluate the performance of the TMC, we know what it takes to manage the traffic and congestion for an incident. But what's the value of it? We compared it with if the TMC was not there, how long would it take to get the information from the field? How long would it take for the first patrol to get out to the field? How long would it get to get the first responders to respond? How long would it take to get the dissipation? And then the difference between the two. So I think a lot of things that Nikola talked about, it just delves into what I'm going to talk about and how we measure the performance of what we are doing. This is This is the big video wall in the TMC here in Orange County. It has capital cost for building the building. It has operation cost, maintenance cost, and for the facility, for the system support, because everything has redundant, HVAC, power, water, everything has redundant system, so it's much more costly than a regular building to operate. Not to mention, it's 24/7, so there are staff working there 24/7 to manage incident, and believe it or not, most incidents happen in the worst time that you want. During the Thanksgiving, during the New Year's Eve, during the Christmas, during the occasion that people, they do not want to be working. So we have a 24/7 operation, and always when we are trying to get funding to manage and maintain our system, there's always questions. What's the benefit of TMC? Look, there are 1, 2, 3 people in the operations floor, and you have a multi-million-dollar building, a multi-million-dollar operation, tens of staff there. What's the benefit of it? So this is the question that we are challenged with on a regular basis. So what is the value of TMC? The direct benefit, restoring capacity, balancing demand, delay reduction, and furthermore, accident reduction, saving life, because a lot of times, the first incident is something minor, fender bender. And then if it happens in an odd time, the trailer comes with a full load, 60, 70 miles per hour. There is not enough time to stop. So that's when the secondary accident happened that really caused a disaster. So lower emission, environmental, and many other benefits. In order to be objective, because everywhere you talk about it, you see there are some benefit to ITS elements. Like they say, even the FHW, there is a benefit analysis that they say each CCTV saves 15% of delay. Each CMS has a changeable message sign or digital message sign. They save maybe 10, they redirect traffic by 10-15%, but I have not seen any objective way of value of what we do in the TMC, and that's what we are trying to pinpoint here. So we are going to talk about only delay reduction. What's the benefit of delay reduction due to presence of TMC? Just like we talked about, we have a daily activity log. I'm not going to get into it. This could be a presentation by itself. The operators manage, they have this logbook. Anytime they get a call, anytime they verify something, anytime they take an action or they see something or they do something based on managing the scene, they log it here. A lot of things is code bases and it's been recorded. California Highway Patrol, they have, which are partnered with us because they're scene manager and we are traffic manager, work together in the TMC operations floor that I showed you. The CHP officer was there as well. They log everything that happens in the field. When the first responder get out there, when the first ambulance get there, when the fire truck gets there. So they track of everything that is happening as the dispatch, as the field officer talks, the dispatcher talks and comes to into this CAD system. And again, this is advanced transportation management system. This could be a good 1 hour presentation by itself. What it does, we have about 6,000 loops, we have about 250 CCTVs, we have about 70 CMSs, and again, some people they call it DMS, digital, and also we have about 330 ramps that are metered on a regular basis. They all come to this ATMS map on different layers, and also we can get reports. So we have speed, volume, queue, delay, everything we can run report on real time based on this ATMS map. So, and also in order to share with other agencies, with other districts, and also with NRICS, we provide, we transfer our data from ATMS map to PEMS, Performance Measure System, which runs reports and tells what are the delay, what are the condition in the freeway. And this is basically open to public on the certain conditions. So it comes from ATMS map. So we have daily activity log, we have CHP CAD, and we have ATMS that has real-time traffic data. And most of the time when there is a system disruption, if there is an incident, just like he showed you the red line on the road, it shows that the capacity is reduced basically to zero in some cases when there's full freeway closure. When there's maintenance and construction, we work traffic around it. And sometimes there's a special event, ball game, sports event, concerts. They all add the demand to the system, but they do not reduce the capacity. So what we are going to talk about only how to manage incident. And the TMC action is in brief. At time zero, when we get when the event is identified, we cannot do anything. Nobody can do anything unless they verify what is the accident. So it takes time to verify the incident, if we have a good CCTV camera for that particular location, as soon as we get a call, in less than 30 seconds we can verify the incident. And that's the time we can take actions, first send first responder, proper responder to the field to do what they need to do. There are locations we don't have camera. We have to rely on the field officers to get to the field to see what is going on. And even Orange County is a small county, it's about 900 square miles. It takes 10-12 minutes for the patrol to get out to the field to verify. So verification could take from 30 seconds to 10, 12, 15 minutes. And keep in mind, every 7 minutes delay in response, there is 1 additional mile of queue built on the system. So it means a lot to be able to verify the incident in a matter of seconds, not minutes. So we identify incident, we verify incident at time T1, we respond by disseminating and sending the first responder to clear T2, and then at sometimes later while we are monitoring from ATMS, we realize when the T3 happens that traffic is restored after the additional queue has been released. So the incident T1, T0, T1, T2, T3, these are the benchmark for doing our performance evaluation. And if the TMC is not there, verification instead of taking T1, instead of taking 30 seconds, could take 10, 12 minutes. And by that time, we have 2 miles additional queue. T2, it might take longer because from the field, practically it takes time for the field officer to call different units to do different things or go through dispatchers to do things. Whereas in our case, CHP is sitting next on the operations floor. In a matter of seconds, they can issue a singular, they can take action, they can send the first responder. So this is the TMC action, and ultimately, if the TMC is not there, all these things will happen, but it happened in a much longer period of time. And the difference between what it takes T3 to T3 prime when the TMC is not there, that's the hardcore objective delay saving that we perform. So again, in the simple terms, the delay without TMC, the delay created without TMC minus the delay with TMC, that's reduction in delay, and that's a direct saving. This is objective that if you by going through this process, there is no subjectiveness into it. That 10 to 15% delay saving, 5 to 10% diversion of traffic. This is just hardcore solid number. That's why I said this could be transferable. If anybody else is interested to do performance management and TMC, everybody has the same data. Nikola showed the same thing. Logbook, real-time information, and patrol or the police department information. So what we do, these are the existing operation database, and through UCI testbed, we imported to another database. We developed a terminology to how to calculate delay, and for the case that we respond late, what happened to the modeling of the queue? Because just like you said, we have anytime that there is an incident, we compare that particular day, that particular time, with 52 of the same day for the same year, for the 52 previous day. For instance, Tuesday 10 o'clock, we compare it with the 52 Tuesday 10 o'clock of historical data that we have. And as a result, the result is another website which we call TMC Performance Evaluation website, which has a user interface, has a security, and it's a web-based. And this is the output of the new production. That TMCPE, this web page gives you a CHP CAD ID for all the incidents, what time it happened, the location it happened, and what happened, what they did to manage the incident. You click on one of those, and this would be the output performance of that the TMCPE application. This shows the location of incident and the impact upstream. This shows the congestion and how the severity of the incident and how far it goes back. This shows the cumulative data, and my next 2 slides I'll show you in more detail. What happened, how much delay, how much diversion of the traffic, and ultimately it gives a report here. If TMC is there, the delay is still there's going to be a delay because there's incident needs to be managed. This is the delay, that's the delay. If the TMC is not there, and this is the saving, and for this particular incident, the delay saving is 39%. And FHWA recommendation is $13 per hour per vehicle, just for the driver cost to see how much the delay is. So when the TMC is here, this is the traffic flow. When there is an incident, the demand reduces, and this turquoise area, this would be the delay. delay, and this would be the diverted traffic. So the demand reduces for a while and then demand goes up. And since you see these two parallel lines, this is just a cumulative flow. So the reason the flow goes like this, because this portion of the demand has, additional demand has been diverted already. So this is the hardcore number. And so at time T3, when the traffic is restored, you see there is no more delay and then it goes as what it's supposed to be. The traffic, the system capacity manage the demand of the system. And ultimately, to go a little bit faster, if the TMC is not there, what you see in this area, this is the additional delay on the freeway system. And the difference between TMC, T3, and when the TMC is not there, this orange line, that's the delay saving for every scene, an incident. And we can capture this accident by accident, incident by incident, case by case. We can look at, run the report through TMCP and see what's the benefit. You can bundle them differently. You can see what happens on the weekends only, what happened after 5 p.m., what happened during this holiday. So everything can be captured. And in general, this is another incident, 51% delay saving, and converting it to dollar is $5,000 saving just for one incident. And this is monthly activity of the TMC. 1,300 accident monitored and managed every month. And first we looked at it, we were in doubt, my staff, they said, Mort, what are you talking about? We don't have that much incident. So let's walk down and ask the CHP. So not ask Caltrans staff, we asked down CHP, and she said 50 to 100 incidents are managed every day. So this is a very conservative number. Not to mention, we monitor 3,800 traffic hazards that if you don't respond fast, this could be a small fender bender and ultimately becomes a major incident. So we are only dealing with hardcore incident that is happening on the system. And I don't have the slide here, but what I did, the cost of, just based on that 1,300 incident, the delay saving that we do on the first incidents based on that 1,300 adds up to about $80 million a year delay saving. The cost of TMC with the capital cost, maintenance, operation, communication, upgrade of the equipment is less than $10 million. So it's very simply, the benefit to cost is 1 to 9. And in fact, still as it's a stage of infancy, we need to deploy this to operation. We need to build the bells and whistles to do real-time delay saving. And there are many other things that we can do to improve the system, build intelligence into the system. So if there is multi-incidents happening, and it happens a lot, 3-4 incidents at the same time, we have limited resources. Based on this tool, if you build on it, if you expand it, we can see where we should be focusing, where should we send the resources first to have maximum, to maximize delay saving. That's my speak, and thank you very much for your attention. Any questions?
You finished in 1 minute. That's great. So we do have time for questions.
So what do you use the resulting performance measures for? To justify budgets? Who's looking at all this information?
Justify budget, look at our own performance, and look how we can improve the performance, and when there are things happening, how we can, what we should do to maximize the delay saving and restore the traffic faster on the freeway system. And sometimes we can run the report and say, how come for this incident it took this much to send the first responder? How come in this case it took this much to send the first responder? Then we can do evaluation. For instance, if sometimes when the fire department comes on board for an incident, and usually they have lengthy trucks, and when they come to the field, they don't really, their concern is not to manage the traffic and have the driver to bypass. They park the car, they park their truck and it's slanted. There is incident in 1 lane or 2 lane, and they park their truck, the engine is slanted, they occupy basically 3-4 lanes and limited. So this tells us in what cases, how long it takes to restore the traffic. And then when we bring it to our management and we have the quarterly meeting with law enforcement and fire department, we tell them that, is it necessary to do this? Can you do better? Compare the incidents and see how long it takes to do things. So has a lot of benefits to how to improve the system.
Do you you have detectors on your arterial system so you can see the relationship between the breakdown on the freeway and the impact on the arterial network?
That's a very good question. There's a federal mandate by November 2016 to have the real-time information on arterials. What you saw here, we only have detection system on the freeway system, and we are working to build detection. In fact, I talked to Ted before, to bring the detection information on arterials to, but what we need volume and speed, and we are working on it as we speak. I have a pilot project to do testing and analyzing.
Can you expand a little bit on how you estimate the delay when there is no TMC?
But
Is
just
it fixed amount of time, or is it does it vary by incident and location?
when there is no TMC, the first responder has to get to the field. And that time is documented in the logbook. So we know it took 10 minutes for the first field officer to get to the field. And we know the real-time traffic volume for that particular day. And we can extrapolate at that speed, at that volume, the queue, how much more it's going to be extended because we have the live traffic volume and speed on the system. And we use that information by that extrapolation for that particular day based on the volume and congestion of the system, comparing with 52 other Tuesdays, 10 a.m. for instance. That's how we build. If the TMC is not there, it takes this much extrapolation to for the first responder. First responder is a punched punch in the log that the first responder got 10 minutes later after the first call. So we know how much traffic, how much queue would be built up based on volume and the condition of the freeway for that particular.
Thank you.
Thank you very much.
So our next speaker is actually the co-organizer of this event, and I'm sure it's known to all. Michael Pack with Cat Laboratory again. When Michael was a very, very young man, he interned
2 years ago.
He interned at R&L, and so we've all been very proud of all his accomplishments since then. Here's the title of his presentation in giant letters. Collaborative decision-making for closures, delayed openings, early dismissal and evacuation consensus building. A little different title in the program. I think what we're going to hear about is how TMCs and the variety of tools and technologies that go into that can be a force multiplier for other types of events and needs. So I'll see if I'm correct, Michael.
Somewhat correct, yes. So, most of what I'm going to talk about today centers around things that are going on in the DC region. And the DC region really is 6 states. It's Maryland, DC, state-ish, Virginia, West Virginia, Pennsylvania, and Delaware. So most of what I'm covering is surrounding those agencies. So we have a lot of hurricanes that come through the DC region. They're not as bad as hurricanes that hit the southeast, but they still affect us. So when a hurricane's coming our way, all the traffic operations people are concerned. They get together and they want to know how bad is this going to really be and are we ready for it? Winter weather. We have winter weather that comes through the DC region all the time, and it can happen late at night or it can happen in the middle of the day when people are already at work. So when we're aware of winter weather coming our way, we want to know how bad is it going to be. And if it's going to be bad, are we ready for it? What are we going to do about it? And then we have unplanned catastrophes. So this could be everything from a terrorist attack to the earthquake that we had a few years ago, which was a really minor earthquake, but it still had some pretty significant impacts on traffic in the region. Then we have power plants and other things that can go wrong, cause problems, and we want to get people out of the region. So, how bad are these catastrophes, and what do we tell people? So those are issues that we face every day up in the DC region. and there's this group called the All Hazards Consortium. It's a group of all the states surrounding the DC region, and they hired us a number of years ago to go in and look at how agencies manage and monitor evacuations, how they decide whether or not to close the federal government or send people home early if there's something coming their way. And what we were asked to do is go out and take a look at all the different evacuation plans that existed, consolidate them together, because Maryland has evacuation plans, DC has evacuation plans, and they don't always match up, they don't always line up, sometimes they can be in conflict with one another. They want us to look at how they're being accessed, how they're being used, and whether or not they're actually understood by the agencies that are supposed to be using them. And so when we went out and we started looking at the evacuation plans, we noticed some interesting things. If anyone's ever read Les Mis, it's something you do in junior high school or something like that. It's a pretty big book, right? It's not the longest book, but it's on the list of longest books. Then you've got the Harry Potter collection. That's a lot of books, a lot of reading. My freshman year anthropology reading assignments looked awful. They were way bigger than all the Harry Potter things. Then after that, you have Encyclopedia Britannica. That's huge. And then you have the state evacuation plans. Those things are massive. I don't know if you've ever seen them, but usually the evacuation plans are sitting in some poor guy's office. They're about this thick. Sometimes it's multiple binders thick. And I would challenge anyone to say that those plans are actually useful when and if something happens, especially if it's an unplanned event. They're not going to go and read all 3,000 pages of that evacuation plan and be able to do anything meaningful with it. So anyway, that's the state of the evacuation plans we saw. And we also noted that in the DC region, every time there's a 4th of July event on the National Mall, you have millions of people come to the National Mall. And so every 4 or 5 years, what the transportation officials do is they get together and they stage people throughout the city, and they pretend like the end of the 4th of July festivities is a mass evacuation exercise. And they try out different scenarios, and they see what works, what doesn't, and they just record lots and lots of data. So we've been recording that information for a number of years, and that's been feeding our evacuation plans. But how does it really happen? How do people decide whether or not you should evacuate? How do they decide whether or not you should close schools for winter weather or whatnot? So what happens right now in DC is there's a recognition that something bad is happening or is on its way. Someone then requests a conference call for the entire region to discuss this. Usually the request is made in the middle of the night, especially for winter weather things. And then an official announcement goes out, says, okay, we're going to have a conference call. It's going to be 3 a.m. Make sure you're there. And then after the conference call, some sort of a decision is made. Is it, tell people to stay home? Is it an evacuation? If it's in the middle of the day, are we going to tell people to leave work early and do some sort of a time release so we don't clog the arterials to get everyone out before the winter weather happens? We're going to close the government. And then they continue to have these calls every few hours, depending on how bad the situation is and whether or not they need to keep monitoring. And I should mention that the transportation folks hate these calls. They're not well done. So why aren't they well done? One, it's a conference call, and it's just a conference call. So what happens is you got the state DOTs, the county DOTs, the local DOTs, National Weather Service is usually there, state EMAs, local EMAs, Office of Personnel Management, the Council of Governments, various emergency support functions, all sorts of other folks. They get on a call, it takes a solid 20, 30 minutes just to do the darn roll call and figure out who's on the call, are the right people there, can they really get started? And of course, there's all sorts of other issues that happen. Once you get into the call, then there's other things that go wrong. Someone didn't understand what someone was saying, they were mumbling. You have to ask people to repeat things, or you forgot what was said. So that's not pleasant. It's not terribly clear who's really in charge of the call. There's someone that kind of takes charge, but it's an open call. Anyone can talk, anything goes. And then who's really responsible for taking notes and recording what is discussed. And there's a real difference between actually taking notes and then turning that into an actionable plan. And sometimes the true intent of the discussion gets lost in these calls. And then of course, everyone on these calls, or not everyone, but a lot of people on the calls, they might have this overinflated sense of importance. And so everyone feels the need to talk and throw in their 2 cents, whether or not they really need to talk or throw in their 2 cents. And so that takes a lot of time. And not everyone's very concise. And then at the end of the call, who's really making the decision to go, no go on evacuation? It's not quite clear. Someone is taking notes somewhere, and that person probably has the bulk of the power. But again, are we really doing the right thing? And then there's all sorts of other problems that crop up. You might have someone who decides to put their phone on mute in the middle of the call, and then we're all listening to someone's on hold music. Or someone starts flushing the toilet in the middle of the call, and you realize they're on the crapper. And there's all sorts of other terrible things that crop up. So just not fun. So we were tasked with going out and trying to come up with a better process. How can we make sure that everyone, one, has access to appropriate plans for the evacuations, but two, how do we communicate that to folks? And then how do we manage these calls in a way that leads to meaningful results afterwards? So we had to first go out and we had to collect data. Now this was fun in and of itself. So who owns these evacuation plans? So we go to a state DOT, and there's usually a state DOT evacuation guy. So we call him up and say, okay, do you have the documents for your evacuation plan? And he says, well, I don't really have it. I'm the evacuation guy, but go talk to this other guy in maybe the GIS department. He's got all those files. And that guy says, well, this other guy is really the one you want to talk to. Please go talk to them instead. We say, okay, thank you. And so then that person that we call and says, no, really, this next guy has all the info you need. This is the one you need to talk to. And then the last person we talk to says, oh, you want to speak to our main evacuation guy, which sends us back to the beginning, and then we realize we're all dead. Because no one actually is in charge of anything. No one has a copy of the plans, and no one knows who has a copy of the plans. So just going out and collecting all the information was a nightmare, and it took a long time. And of course, some people have those files digitized. Most people don't. So we did have to go digitize them. Then we found out that at the borders between states, you sometimes have people that are sent, like Maryland might say, this route here, Route 3, I'm making that up, is our main evacuation route out of the state. And when we get to Delaware, you find out that Delaware's closing Route 3 at the border and doesn't want anyone to use that route for whatever reason. So we had to consolidate those things. Different people are using different coordinates, different mapping systems, different base maps. And then it's a lot of information. And some evacuation scenarios are scenario specific. It's not just here's an evacuation plan. It's for specific scenarios. So we wanted to be able to get to the meat of that, and then we needed a way to distribute it. So Nikola was just up here talking about this RealTime and some concepts of dashboards we're working on. RealTime has become the de facto evacuation resource for the region. That's where we store all the plans right now, and we also publish the evacuation data through something called the Geospatial Data Exchange Hub, which is in the DC region as well. So what types of information do we now have visible? Well, we have something called staging areas. Staging areas are locations that have been identified as having excess parking. Places where you could stage people, equipment, goods, stuff like that. So we have all these things mapped, which is nice. Anyone can build a map, but then when you click on individual areas, it tells you, okay, well, here's the location, here's the phone number, here's how many parking spaces are available, and then we pop up an aerial picture of the location and showing you where the access points are to get into or out of that particular staging area. We've also then mapped all the hospitals, and all the hospitals have the number of beds that are available in each of the hospitals plus the phone numbers to get to that particular facility. Then this is particularly cool. We have traffic control points. So we've identified all of the intersections in this 6-state region that need to be monitored or controlled in a special way during a type of evacuation. So for each one of these intersections, you click on them, it pops up a diagram of the intersection. It shows you what the flow of traffic should be. If you need to deploy cones or set up roadblocks, it shows you where you need to deploy that. If you need to retime the signals, it shows you how you need to do that, so on and so forth. And this is scenario specific, so each intersection might be controlled in a different way depending on what's going on. So getting to that, you can filter all the evacuation routes down. So you can go in, you can select a region that you need to evacuate, and then you can go into the region and there might be different plans. So this is DC, and of course one of the top things they have here is, okay, let's get people out of the White House, get them safe. So you can click on that and it just brings up the things relevant to a White House evacuation. And we do the same thing with all of the routes. So we can show you the specific routes that are designated as evacuation routes, which will be controlled and monitored in a particular way. So all that's available, but that's just having the evacuation data in one central repository. That doesn't really solve all the issues that we're dealing with here. I forgot one other thing. So if you are trying to evacuate a particular area, you need to reach out to the right folks to let them know that they need to evacuate. So we then identified all of the businesses and all of the schools and anything that's got an address and a contact information with it. We've got that. So you can go into our system and you can type any category of business or facility or whatnot. And then, of course, maps those for you. Or if you need to evacuate a specific area because there's a plume of some sort of poisonous gas, something like that, you say, okay, well, here's my area, and it brings up all the schools within that area. And if you click on them, it then shows you the phone number for reaching out to that school and letting them know the duck and cover. Then what we're doing is we're working with the Johns Hopkins Applied Physics Laboratory to take some of their real-time evacuation modeling tools. It's essentially, okay, I need to evacuate an area, I'm going to select a region, and instead of having to wait 3 days to get the results of your simulation model back in 5 minutes, it comes back and tells you, okay, here's how long it's going to take you to evacuate this area based on time of day, census tracts, all sorts of other stuff. So that's being built into the system. But anyway, how do we make all this information now available on these phone calls so that people can make better decisions? So we've identified all the experts that are part of this call. We've had several brainstorming meetings with them. We're developing prototypes of tools that can be used during the call to make things go smoother. We're redesigning the prototypes, so on and so forth. And what we've come up with is something very similar to what you'd see in a lot of web meeting applications. We essentially, everyone when they call in, we have their phone numbers on record. We'll be doing some sort of call management so that we know who's on the call. We don't have to go through this terrible roll call process anymore. Then our RIDIS maps and weather information will be visible to everyone, and whomever is in charge of the meeting can then draw and annotate on that, show people the various evacuation scenarios, show people what the expected snowfall is going to be, so on and so forth. The weather reports are there, so you don't have to repeat them over and over and over again. But the coolest thing is every agency gets to vote on what they want to do. So they might vote on something like, the DOTs might vote on whether or not they're going to have the roads clear by a certain time. And so DDOT would vote, MDOT would vote, VDOT would vote, and they have different weights assigned to them. So a local DOT might have a different weight than a state DOT, and so on and so forth. And all those votes get recorded, and you do things about traffic, you look at safety. We're trying to look at the economic indicators. So if you close the federal government, how big of an impact is that going to have on the region compared to traffic flows and so on and so forth. And all these votes are recorded and weighted, and that then turns into a recommendation that says, okay, we should remain open. We should do a delayed opening, or we should just close the government for the day, or we should implement this particular evacuation plan, tell everyone to get out, so on and so forth. So the outputs is a single view of the event. Everyone's looking at the same screen, they're seeing the same thing. After you've had the call, you're able to print out and email a record of the votes to the actual decision makers. Much faster call management. You don't have to do this roll call anymore, and it's a more open and transparent decision-making tactic. It's no longer just we had a call and this is what someone recorded. And you can keep monitoring the event. Nikola showed you earlier, we've got speed data coming from probe data providers and also show those, so you can actually see how well the evacuation is going. So some of you might be wondering, why aren't we just using a commercially available web meeting software tool? Well, we tried that. We actually did some experiments with a few of our user groups. And what we found is that web meeting tools are like taking a nuclear weapon to a fist fight. There's all these capabilities in them that we don't need, and which actually confuse people when there's a real catastrophe and people are scared and they just want to make a decision really quickly. So we also don't want people to have to be forced to download some new software every time there's a catastrophe. We want them just to be able to go to a website and there's the information. And simplicity is really key. Have as few functions as possible, have as few visualizations as possible, so you don't have to be a rocket scientist to be able to make a decision. It also makes the moderation much easier. You don't have to set up files and share desktops and do all this other stuff. And this direct printing and sharing of the meeting results was key. So our next steps, we're finishing our hopefully last round of design reviews, and we're currently working on the building out of the voting functionality. We do have the screen sharing and a few other things working right now. We're still working on the call management side of the thing too, so we can tell who's actually called in. And I think I've now gone over my time, but that's what we're working on for trying to make it easier to make these evacuation and closing decisions. Questions? Yes?
I do look at a tool called Decision Lens.
I have not.
Because it has pretty much exactly what you described. It's used mostly for budget decision.
Mm-hmm.
But you have a lot of people, different voting, comparison between votes, and pretty much the ability for every one of the users to input their concerns.
Mm-hmm.
That specific things.
It's called Decision
Lens.
Lens? Okay, we'll take a look at that. Thank you. Anyone else?
Two questions. Do you use the gold disc data for location of schools, international schools and hospitals and other population centers?
We do not. We actually use commercially available data from like TeleAtlas or Navtech or some of those folks, and then we supplement with local data as needed.
And then the second part of that is, do you share this or do you receive input from the fusion centers in your
So Fusion Centers is, are we still recording this? Fusion Centers mean a lot of different things to a lot of different people, and in DC it's not clear what it means. Fusion Centers are generally, in the DC area, it's a group of people sitting around in a room, kind of like a traffic management center, and they're just watching screens and TV and Mort and that sort of stuff. We are acting like a fusion center in terms of the data collection and dissemination, and they have access to all these tools. We have about 3,000 people that have access to the tools in the general national capital region. Yes?
How did you decide the voting weighting system, and does that are those votes binding when it comes down to, you know, sort of go, no-go decision?
So that's a good point. None of this is binding. So the way the call really works is all these people have this big discussion and make a recommendation. The recommendation then goes to some executives in, you know, at Office of Personnel Management and some other higher ups in federal government. They just look at the data and they're the ones who ultimately make the decision. The weights are fairly simplistic. It's, you know, if you're a DOT, you're in charge of the roads, so you have greater input into whether or not you think the roads are going to be clear and open and so on and so forth. Office of Personnel Management or some of the EMAs, their votes almost don't count at all. Those sorts of things.
Following up on that question, do the executives that are making the decision on this recommendation, do you think that they see sort of the inefficiencies now in existing sort of conference call situation, and do they see a bite of this kind of a secret model?
So the executives are actually making the decision at the end. I don't think they're aware of the process, because they're just handed information and then they make a decision. So I don't know if they care. I could be wrong, but I'm not aware that they're aware. Anything else?
One last comment. Each agency would have its SOP, standard operating procedure, and like the books that you showed there. Do you have a means to have like a library function where people could, during the call, go reference what's supposed to happen as opposed to just this ad hoc voting situation?
So the state DOTs have a regional SOP for how they are supposed to be working together and making some of these decisions. The EMAs and the other folks, they've got SOPs for dealing with their own organization, but there is no SOP for all of these groups working together. It's very ad hoc, which, you know, we're trying to make it a little less ad hoc. This isn't going to solve all problems. Just trying to help a little bit.
Due to the chaos and the variability of any major event, though, I mean, it's just an opinion. It could be a blessing that there's ad hoc and a little bit of chaos in there, because everybody's dealing with real-time information or near real-time information. They're adjusted to the specifics of that moment in time. I guess, I don't know, I don't think that'd be a strength.
So that's interesting that you say that, because there is, I won't mention the agency, but there is one agency that refused to give us any sort of evacuation plans, because they say there is no point in having evacuation plan because everything is dynamic and, you know, there's no one plan that can fit all. And they said, we have a group of people. There are evacuation managers. When there's a need, they get together and they know they're on call 24/7, and they're the ones who come up with a plan right then and there. So I think maybe a mix of the two is more appropriate, not
Sort of planning a direction, but knowing it's going to change at any given moment.
Yeah.
One last question? Okay. Thank you.